Hey everybody, welcome to part 2 of the evolution of a video game. Today I want to talk about what our team has done for milestone 2 and give you an idea of where we want to go from here. If you look back at the previous video, you'll see the very basic beginnings of a game with not much functionality implemented. We had a few things drawn to the screen, crude player animation, basic collision detection, and a few buttons and sticks working from the gamepad. We also had one procedurally generated level that would scroll from side to side as you moved, and a few art assets that weren't yet incorporated into the game. In this milestone, we wanted to have a playable prototype that gave a good general idea as to how we wanted the game to look and feel. To that end, we added level generation for multiple types of games, including search and destroy, base defense, and escape from danger, with the search and destroy level being the one shown in the previous video. We also added full dynamic player animations that change based on where you're aiming and the direction that you're walking. We added game states including menus and splash screens such as the pause state or the startup game state, with the menu letting you choose where you want to start. We also have a HUD that shows what player you are and how much health you have. We have implemented more particle effects such as bullets, flamethrowers, and explosions. And we've added more art assets that are actually in the game now. So I'll go through each of these briefly and explain what each of them are in more detail. You start off at the main menu, which right now is just a selection screen. You'll immediately notice that the game seems more fleshed out, with the ability to choose a character, swap weapons, aim, and shoot. Much of the art for this search and destroy level has been added to the game, and you can now shoot and kill the enemies. The AI for the enemies is pretty simple. They try to get within a certain radius of you and shoot as fast as their gun will allow. You take damage as you get hit, and your health meter depletes accordingly. Enemies that you kill just disappear, but we plan to change that in the future. Another thing you'll notice is the fluid animation. We kept the body, head, and arm/gun sprites separate. This means that we can manipulate them individually based on what the player is doing and play things such as the walking animation forwards or backwards. Our next level is base defense. In this mode, you'll be protecting some important scientific thing from the evil minions, and the goal is to keep it from taking some certain amount of damage before the time period is up, or you kill all the enemies. We haven't decided which yet. The art for this important piece of machinery hasn't been made yet, so that's why you don't see anything here. One problem you may notice is that when I jump up onto this platform, the enemies aren't able to shoot me. This is a problem that we will be addressing shortly. The last level that we currently have a prototype of is Escape from Danger. The idea behind this one is that you just killed a boss, and right before dying, he launched a missile barrage at you, causing you to have to escape the facility or die in the resulting explosions. The goal of this mission is just to make it out to the end without falling into the death trap behind you or getting killed by the enemies that are desperately trying to seek revenge. The missiles are a one-hit kill, as you can see from the minions that are dying behind me. These missiles are shot using the particle system, which we have implemented and created to be very flexible and powerful. In our code, we use an object-oriented design, so one of our emitter classes is a projectile emitter. From it, we derive subclasses such as the missile launcher, bullet emitter, and flamethrower emitter. Each of these has similar functionality, but they're all customized with respect to the general projectile class. We have a similar object-oriented design when it comes to the people on the screen. We have an actor class that each actor derives from. The reason that we would derive classes like player and enemy from actor is that while they do share common characteristics such as a location, a projectile weapon, inputs, and screen drawing information, the differences would be something like a player gets his input from the controller while an enemy gets his input from the AI. Using an object-oriented design makes things simple and intuitive, so that an actor has an abstract method called getInput, which the player and the enemy classes define separately. When an actor calls his getInput method, he'll really be calling the method that belongs to whatever class he is. We made an effort to use good programming principles like these in other areas, such as in our menu, controller, and level classes, so that our code is clean and efficient, while making errors easier to spot and fix. The way we do collision detection for weapons is by combining the interfaces of the particle system and actor. Each bullet is represented by a particle in the particle system, and every frame, each bullet will pull the system for the nearby actors. Each actor has a square hitbox, so to see if someone has been struck by a bullet, each bullet checks to see if its location is inside a hitbox. If it is, it tells the actor that it has been damaged a certain amount, and then the bullet removes itself from the system. If the bullet isn't inside a hitbox, it'll just be checked again next update. Collision detection can be complex and computationally costly, but by only checking actors in the vicinity of the bullet and using squares as bounding boxes instead of doing something like per pixel overlap checks, we can perform fast checks with points and rectangles. The downside to this method is that for large sprites with erratic, non-rectangular shapes, the lack of precision on account of using rectangles would be pretty obvious. Imagine drawing a circle and then drawing a box around it. A collision check using this system would record a hit anywhere in the box, even if it was outside the circle. One possible way to improve on this algorithm is to subdivide the one hitbox into multiple hitboxes that more accurately represent the model that you see on the screen. I've skipped over a lot of the details of how our code works, but I'm interested in what you guys think about the game so far. Do you have any questions that relate to coming up with ideas, filtering out the good ones, or implementing features in code? I'll try to answer any questions that you have, and if some particular thing is of interest to you all, I will try to explain it more in the next video. Feel free to leave comments if you have a question or a comment about the game, as we'd love to hear it. I've compiled a build of the game in its current state and made it available for download on the project website. All you'll need to install it is the XNA Redistributable, which isn't that big, and I'll link to both in the description below. You'll want a gamepad to play it, though we do have limited debug controls using the keyboard. Up to 4 people can play, so grab some friends and frag away. Thanks for watching, and I'll be back again for our next milestone.